Hello geometry students, here's your final lesson before spring break, section 9-2, developing formulas for circles and regular polygons. Missy McCarthy, Okemos High School math teacher. So in this particular lesson we're going to develop and apply the formulas for the area and circumference of a circle, which you already know a great deal about. And we're also going to develop and apply the formulas for the area of a regular polygon. So for circles, just a couple things. A circle is the locus of all the points in a plane that are a fixed distance from a point called the center. When we name our circles, we usually put a little circle center with a dot in the middle, as you can see here, and then we put the letter of its center. So if you look at this circle, we can see all the different parts of it. We could name the center. We could say that was center C, that point in the middle of the circle, and all of the points on the circle are equidistant from C. So we would call this circle C, so we could definitely do that. We know that the radius is the distance from the center to the edge of the circle. So you can see your radius here from the center to the edge of the circle. We know that the diameter is actually the distance all the way across from side to side, and it passes through the center. So the diameter of a circle is equal to 2 times the radius of a circle. And then the circumference of a circle is the distance around the circle. So you can see here we have the circumference of that circle.
Here is a circle, it knows how to get around. It has a radius from center to rim, and its diameter's a line that goes from side to side while passing through the center. Now isn't that simple? Pi r squared sounds like area to me. When I need a circumference, I'll just use pi d. Pi r squared sounds like area to me. When I need a circumference, I'll just use pi d. Here is a circle, it knows how to get around. It has a radius from center to rim, and its diameter's a line that goes from side to side while passing through the center. Now isn't that simple? Pi r squared sounds like area to me. When I need a circumference, I'll just use pi d. Pi r squared sounds like area to me. When I need a circumference, I'll just use pi d.
We have a couple of equations that we can remember quite easily. The one equation that we need to keep in mind is the circumference of the circle, or the distance around the circle. And the distance around the circle is always pi d, or if you replace d with 2r, you could write 2 pi r. And then the area of a circle, another formula you should be quite familiar with, is pi r squared. So let's use those formulas to find out some things or to solve some problems using about circles. So if we look at this one, it says find each measurement, and the area or the measurement that we're trying to find is the area of circle K, and it says leave our answer in terms of pi, so don't multiply it out on the calculator. You're going to have a pi in your answer, and don't forget the units. So for K here, if we're going to find the area, we know that the area of a circle can be found by doing pi r squared. So if I substitute in the radius of the circle, if the diameter is 6, then the radius of the circle right here is 3. So 3 squared. So our area becomes 9 pi. And we need some units. The diameter was 6 inches. So that means our area is 9 pi square inches. Now for this one, they're asking us to find the radius of circle J, given that the circumference is 65x plus 14 pi meters. So we don't have a circle K here, or circle J. We could draw it if we wanted. Put J in the middle, and then there's our radius. And if they give us the circumference, we can use the circumference to find the radius, and then use the radius. Actually just use the circumference to find the radius. We don't have to find the area here. So we know that the circumference of a circle is 2 pi r. I'm using 2 pi r instead of pi d because they asked me to find the radius. So I'm going to substitute in what I know. I know that the circumference is 65x plus 14 pi, and that's equal to 2 pi r. Now if I want to solve for r, because I was asked to find the radius, I just need to divide both sides by 2 pi, and this should be in parentheses. Okay, so then when I divide by 2 pi, the pi's actually cancel. That cancels with that, and then we just need to divide that by 2. So 65 divided by 2 is 32.5. So we have 32.5x plus 7 equals r, because those guys cancel. And again, I don't want to forget my units. It's 32.5 x plus 7, and then my units in this case are meters. So that would be the radius. And then if we were asked to find the area, we could just plug r into pi r squared and find the area. All right, so now we're going to talk a little bit about a regular polygon. If you recall, a regular polygon is a polygon that has all congruent sides at all congruent angles. So here you can see that all of the angles are congruent and all of the sides in a regular polygon are also congruent. Now similar to a circle, a regular polygon has a center. I'm going to call that center point A. So the center in this circle would be A. And then they also have a radius. The radius is from A to the vertex. So we could say that AB, segment AB, is a radius of the polygon. Okay, so that's another thing to take note of. They also have something called the apothem, and the apothem is just the distance from the center perpendicular to the side. So the apothem in this case would be from the center perpendicular to the side. So the distance from center perpendicular to the side. Okay, and I'm going to call that apothem little a for apothem. And then the central angle then is the angle that's created between two radii of a regular. So the angle between two radii. So let me draw this in another color here. Let's grab a blue. Okay, and if I were to start at A and go to here, that's one radius. Here, that's another radius. This angle right here would be my central angle. Central angle. And there will be several of those for as many radii as we can draw. If we drew another radius there, and another radius there, and another one, oh, we got that one in there already, and that one there. So this one would have 1, 2, 3, 4, 5, 6 central angles, and they will all be equivalent or congruent. All right, so let's see if we can develop a formula for the area of a regular polygon. So we're going to use our area of a triangle formula and see if we can't use that to help us identify what a formula would be for the area of a polygon. Well, why are we going to use the area of a triangle? Well, let's put our center point here, and we're going to call that P. So if we were to draw all of the radii in here, Okay, you would see that we have a 1, 2, 3, 4, 5, 6, 7-sided figure, and we end up with 1, 2, 3, 4, 5, 6, 7 triangles that are isosceles because all the radii are congruent. So that's congruent to that. So if we can find the area of just one of these triangles, then we could just multiply it by the number of triangles that we have or the number of sides that we have, and then that would give us the area of the entire figure. So the number of sides that we have, we're going to say that that's n equals the number of sides. We're not going to do it specifically for this one that has 7 sides because we want our formula to be universal for all regular polygons. So n is the number of sides that we have. Now if we're going to find the area, let's just look at one of these triangles. We know that this is our radii, or radius, or these two are radii, maybe we should say. And if we were going to find the area of this, let's call this part here, let's call this our base or our side. I'm going to call it S for side, because that's for one side of the triangle, or of the polygon. And if we were going to find the area of this guy, we would need to know the height. But the height has a special name. What did we call that previously? We called that the apothem. A. So if we can find the area of this one triangle, then we can multiply it by the number of sides that we have, and that will be the area of the entire figure. So the area of this one triangle would be 1/2. The base is our side length, S, and the height is our apothem, A. So that's the area of one of the triangles. So the total area, the area of the entire polygon, would end up being 1/2, or how many of them do we have? Well, I'll multiply later. It will be 1/2 the side lengths times the apothem, and then we got to take the whole thing and multiply it by n, because n is the number of sides or the number of triangles. So multiply that by n. Well, one thing that we notice, if we take n and multiply it by a, what is that? By s, excuse me. N times s would be 1, 2, 3, 4, 5, 6, 7. That would be the perimeter of the figure. So if the perimeter is equal to the number of sides times the length of the side, then we can substitute that and get a formula for the area of any regular polygon, and it's just going to end up being the apothem times the perimeter. So the area of any regular polygon is the length of the apothem times the perimeter. So here's our formula for that. Any regular polygon, with the apothem being the distance from the center perpendicular to the side, is equal, the area is equal to 1/2 the apothem times the perimeter. All right, so let's use that formula to find the area of this regular polygon to the nearest tenth. It's a regular heptagon, so because it's a heptagon, we know it has 7 sides, so we know that n equals 7. Just going to put that in there. And we know that the side length of this heptagon is 2. So this is 2 here. So if we're going to find the area of it, we need to use the formula. Area equals 1/2 the apothem times the perimeter. Now we can find the perimeter because it would just be 2 times 7. It would be 14. Well, P is equal to 2 times 7, which is equal to 14. So we're good there, but we have to find the apothem. So how can we find the apothem? Well, I'm going to draw my center in here, and I'm going to call this point P, and then I want to know what my central angle is. Well, all the way around is 360. So because I have 7, if I do 360 divided by 7, I end up with 51.4 degrees, and that's going to be my central angle. 51.4 degrees. So if I draw my apothem, I'm going to call that A. Now I've just divided that central angle in half. So if I divide that by 2, now I have a right triangle. I'm just going to reiterate what that right triangle is. This is my radius. This is my apothem. This is perpendicular. This side length now, because the whole side length is 2, this side length is 1. And I know that this angle is 25.7 degrees. 25.7 degrees. So now using all of that information, I can find my apothem. If I do opposite and adjacent, if I do tangent, I can find my apothem. We don't need to find the radius. So I'm going to do the tangent of 25.7 degrees is equal to 1 over A. So I would get A is equal to 1 divided by tan of 25.7 degrees. So 1 divided by the tangent of 25.7. And that gives me that the apothem is 2.08 units long. So now that I have my apothem, I can plug that in with my perimeter, and I can get the area is equal to 1/2 the apothem, which is 2.08, times the perimeter, which is 14. So 7 times that answer. Oops, sorry. And we get that the area is 14.54 square feet. And there we have it. Now let's find the area of this regular polygon, but this time instead of giving us the side length, they've given us the radius. So we're still going to have to find the apothem, and we're actually going to have to find the side length now, and we're going to use those to find the perimeter and overall the area. So I am just going to draw, well, let's see how many sides we have. 1, 2, 3, 4, 5, 6. So n is equal to 6. So now we can figure out what our central angle is. It's 360 divided by 6, which is 60. And now one of our triangles would look like this. This would be 60, this would be 10, and this would be 10. So when we draw this down for our apothem, now we've just created a 30, 60, 90 triangle, which is beautiful because we can use what we know about a 30, 60, 90 triangle to find our side length and to find our apothem. So for our 30, 60, 90 triangle, if the hypotenuse is 2, then we know that is 10, then we know our shorter side is half of that. So this is 5. So this whole thing right here will also be 10. And then we know that the apothem would be 5√3 because it's the length of the shorter leg times the square root of 3. So we know our apothem. We can find our perimeter. There are 6 sides, and they're each 10 units long. So our perimeter is 60. And now we can find our area. Area is equal to 1/2 times the apothem, which is 5√3, times our perimeter. If that's 5, then that's 10. Yeah, I did that right. So that's 60. So I'm going to do, I think it's going to be 150√3. 5 times 60, and then divided by 2. And so, yep, our area is going to be 150 square roots of 3, but it's set round to the nearest tenth. So times the square root of 3. And that gives me an area of 259.8 square inches. Inches squared. Okay, so that's how you would do a problem if they give you the radius. You have to find the apothem and the side length. All right, so here's our last one. Find the area of a regular polygon if it's an equilateral triangle and they tell us the apothem is 2. So this is lovely. They already give you the apothem, but we still have to find the side lengths. So, and it's equilateral triangle. So we know that n equals 3. It has 3 sides. We can find our central angle really easily. It's 360 divided by 3, which is 120 degrees. So when we drop our apothem here, our apothem is 2, and this is 60 degrees because the whole thing was 120. and that makes this 30, which is nice because we have a 30, 60, 90 triangle again. Now we don't need the radius, all we need is this side. So if we look here, across from the 30-degree angle is 2, so the longer leg is going to be 2 root 3. So if that's 2 root 3, then this whole leg is 4 root 3. And if that's 4 root 3 and it has 3 sides, we would have 3 times 4 root 3 for our perimeter, which is 12 root 3. Now we can find our area because we know the apothem. It's 1/2 of the apothem, which is 2, times the perimeter, which is 12 root 3. And that's going to give us, let's see here. That's going to give us approximately, it says round to the nearest 10, so it would be 20.8 square feet. And that would be it for the area of that regular polygon. So we've done 3 examples now, one where they give you the side length, one where they give you the radius, and one where they give you the apothem. All right, make sure you rewatch any parts of the video to make sure you understand the formulas for circles and regular polygons. Again, as in the last lesson, all formulas should be memorized. Feel free to type questions in if you come across any, and we're going to do the same thing in class tomorrow with the lesson quiz and worksheets. See you then.